What is analog signal? What are analog signals in communication? Now the first thing is, everything is in this world is analog. Okay? A kid is speaking or singing. Now whatever he is speaking or singing, it is an analog signal. Okay? Now you'll see what the definition means. You will actually know the analog signals, but the first thing is, all signals that are natural or come naturally are analog signals. Even the lightning is a signal. Okay, that is naturally occurring. You're speaking, you're shouting, you're dancing, you're communicating. All these are naturally occurring signals, and they all are analog signals. Okay, so anything which occurs naturally is analog signal. Or you can say a signal in which some feature, it can be any feature, it increases and decreases in the same manner or in the same way as the thing, for example, the sound here in this case of the kid, the same way as this sound is being transmitted. Now when he is actually loud, you see a high amplitude. When he is not loud, the amplitude is low. So it is increasing and decreasing the way he is speaking. Okay? So a signal which is a continuous function of time, this is very important, continuous function, there should not be any breakage, and it has to vary according to the time. So if you make a graph, there will be no breakage, there is no breakage. It will always be continuous, there is no breakage, and it is used to carry the information. So it is a function of time. So the voltage or any physical entity you take, okay, voltage or current mainly in analog signal, it is a continuous function of time. And then the representation of this is analog signal because it is carrying the information. Only the continuous function of time is not enough. It has to carry the information, and when the kid is speaking or singing, the data is converted into information, and that information is transferred as audio signals. And these audio signals are nothing but analog signals. Analog signals, they employ the properties of the medium to convey the information. Because when you speak to someone, you are using the air. Actually, you push your air through your sound waves, and those waves travel and it reaches the ear of the other person. That is how he is listening. This is analog signal. Analog signal is a continuous signal. Now this is continuous. There is no breakage. It's continuous. So you will get at every x some value of y. So in which one time varying quantity represents another time based variable. Here the time is on the x-axis, and on the y-axis you have voltage or a current or anything. It can be any value. So analog signal is continuous, and one time varying quantity represents another time based variable. For example, this picture also is showing the analog audio signal. The instantaneous value of signal voltage represents the pressure you are putting as a sound wave onto the environment, onto the medium, and that is how the conversion is taking place. You are pushing it, and that push and that pull, or little push or high push, that is actually forming a waveform, and that waveform is analog signal. Okay. Now this particular value of voltage, for example, on the y-axis we are having voltage. So this voltage is actually showing at this particular time what is the pressure or the thrust or the loudness of your voice. Now one thing you will not hear anywhere, this is a very typical thing about analog signal. Any waveform that is continuous in both time and amplitude is an analog waveform. It is not an analog signal. Okay. Now this, see the upper part and the lower part, these are just amplitude, and time is already on the x-axis. So it is time varying. When the time varies, there is certain value of voltage. Now this waveform is called analog waveform because it is continuous in both time and amplitude, right? So the sound waves you see here is making a waveform which is an analog waveform. While an analog waveform that happens to convey information is an analog signal. It is not bits or bytes here. Okay, please remember. Analog waveform that conveys information now becomes analog signal. An analog signal is continuous. There is no breakage. Now you understood that. If it is continuous, that means it can take infinite values. At every x-axis is t. So let me make it as t comma v. V can be any value. It can be voltage. It can be current or other. So at every t, you will get some value of v, some value of voltage. So that is why it can have infinite values. The output you generally see in analog signal as the form of sine wave. It is not always. The output form of an analog signal is similar to a curved line. It can be any graph. So it can be a straight line also. Now just imagine you are riding a bike. You start with 0 and reach an average speed, constant speed. That will be a constant line, it will be a straight line. Okay. So analog signal can be defined with respect to various quantities. The prominently amplitude, time period, you can call it as frequency only because they are just reverse of each other, and phase. Amplitude, frequency and phase. Frequency is almost related to wavelength. Okay, inversely related to wavelength. Amplitude is what? The highest pitch of the signal. Okay. Frequency is rate at which an analog signal varies. Now you see, when we change the wavelength, the frequency also changes. So frequency high, the wavelength is high, frequency less. Wavelength low, frequency high. And what about this frequency and amplitude? Along with this, we have a phase. Phase is just the position of the signal relative to the zero time. That is, in this x and y, when they cross each other, that is 0, 0 point. From here, the position of the signal relative to the time nothing, which is 0, 0 in this case. So these amplitude, frequency and phase defines an analog signal. So analog signals, because they are naturally occurring signals, if we are around say 10 meters, we will be able to hear 2 meters very clearly. But if it is 100 meter, we will not be able to hear it. Analog signals are more susceptible to electronic noise and distortion, which can degrade the quality of this signal. This doesn't happen in the digital signal. Please remember.